Okay, so the next method we're going to learn is to solve by substitution. So I didn't write this on your note page, but so you don't need to write notes on this, but you can if you want. The idea though is if you have y equals 2x plus 1, and then you have another equation that says, I don't know, 3x plus 2y equals 6, then because you know y equals this, 2x plus 1, you have equivalent values. You have a value for y, or an expression for y. So you're going to plug that in the other equation for y. And so you would write it 3x plus 2, and then you're going to put in not y, but 2x plus 1, an equivalent expression for y, and then equals 6. And then that you can solve. But that's the idea. Okay, so here we go with our example. Solve, whoops, I'm going to back up for a minute before we do the example. So the goal to solve by substitution, get one variable by itself. It doesn't have to be y, it could be x, but you just need like y equals something, or x equals something, and then you can do a substitution. Okay, so now we're ready to do the example. So I'm looking at my system here, and I'm saying, okay, is there an equation where like I have either an x or a y that's almost by itself? And I'm going to say in the top equation, this y looks very promising. So I'm going to rewrite that equation, negative x plus y equals negative 5. And if I could just add x to both sides, then those would cancel out. I'd have y equals x minus 5. And so now I have that situation where y has an equivalent expression. So I'm going to substitute x minus 5 into, and you have to make sure you go to the other equation. Don't substitute back into the same equation. That'll be not right, okay? All right, so now what I do is I copy down that bottom equation, 2x minus 5, but then I don't put y, I put what y equals. Okay, that's the substitution right there. Oops. You have to continue writing the equation. So notice you have the 2x, that's the same, the minus sign's the same, the 5 is the same, but now we don't put the y, we put what y equals. And then you have to finish it off. You have to put the equal sign and the 1. Okay, now, it's like if you were having a dinner and the dinner plate had green beans, and you didn't like green beans, but broccoli had just the same amount of nutrition and calories, and you liked broccoli, so you make a substitution. You take the beans out and you put the broccoli in. So what we did was we took out the y and we put in an equivalent expression. Okay. Now, the great thing about this is an equation that can be solved because it's in one variable. So 2x, I'm going to have to distribute, that's a negative 5, so minus 5x plus 25, negative 5 times negative 5 equals 1. Okay, so now I'm going to have a negative 3x plus 25 when I simplify. Subtract 25 from both sides. Ah, the fun algebra. Negative 3x equals negative 24. Almost done. Divide by negative 3. And we get x equals 8. And at this point, a lot of times students are, yay, I got the answer. Well, you only got part of the answer. You got x equals 8, but you still have to find y. Remember, we need ordered pairs. So you're going to go back to your equation, your substitution equation. I really wanted to write that in orange. Okay, so back to the substitution equation. But now you can substitute in the value for x that you just figured out, 8. And so you get y equals 3. Okay, some textbooks will just write x equals 8, y equals 3. A lot of times, though, they want you to write it as an ordered pair, so 8 comma 3, x comma y. All right, and that is the point that will satisfy both equations, make both equations true.